Today we will discuss the last topic of Unit 2, that is Introduction to Load Frequency and Voltage Control. As we know that power demand on any station is not fixed, whether active power demand or reactive power demand. It is variable. At each moment it varies. So for a given demand, active power demand and reactive power demand, our duty is to match the corresponding demands by generating appropriate active and reactive powers from the various units. Right. So till now we have studied for a given demand, active demand, how to load the various units available in the station optimally. So if demand is not matched, then what will happen? Suppose active power demand is PD on the station and you are generating lesser than that. In that case, it will affect the frequency of generation. Frequency will be lesser than the desired, right? And vice versa. Suppose you are generating your active power more than the demand on the station. In that case, what will happen? You are generating more. In that case, the frequency of generated power will be more than the reference frequency, desired frequency. So we have certain limits of frequency also. Otherwise, it will affect the quality of the power, right? So we should not generate our active generation. We should not allow the variation of active such that the limit of the frequency is violated. The limit of frequency must be within maximum and minimum allowable limits, right? F min and F max. That is very less, right? So for India, our reference frequency is 50 Hz. So we try to maintain our frequency of generation at 50 Hz. But slight variation you can observe in your labs also, right? 49.95 like that, or 50 point something 0 something 1, right? So very small range of frequency is allowed. If the frequency of generation is beyond those limits, whether crossing upper limit or lower limit, more than the upper limit or lesser than the upper limit, that is not desired. That's why continuous control of the active power generation is required. So how that control is done, we will discuss later. Similarly, for reactive power demand, you have to generate the similar reactive power from the plant. If you are generating lesser than the desired Q, reactive power demand, it means it will affect the bus voltages of various buses of the system. So for bus voltages also, you are having certain limits, Vmin and Vmax. Maybe plus minus 5%. Suppose ideal one, you can take 1 per unit. So 0.95 per unit to 1.05 per unit is the limit for plus minus 5% allowable change in voltages. If you are going to generate your reactive lesser than the desired one, it means the reactive power demand is not matched, right? If you are generating lesser, it means the voltages will be below the desired. If you are generating more than the desired, suppose on your plant your Q demand is QD, suppose like PD, active power demand, similarly QD. If you are generating more than QD, it means the voltages may cross the upper limit. So over voltage is also not desirable, under voltage is also not desirable. That's why continuous control of both active and reactive power generation is required. So this comes under control of frequency and voltage. So frequency will be controlled by controlling active power generation, and voltages will be controlled by controlling reactive power generation. And we have to control these two quantities continuously, as the active and reactive power demand both are not fixed. Both demands are varying with the time. Is it clear to you? So in case of turbo generator, to control frequency, the steam input to the turbine will be controlled. In case of hydro generators, hydro power plant, so there we have hydro turbine. So water input to the turbine will be controlled, right? So we will have some reference frequency, and frequency of generation will be continuously compared with the reference. Suppose reference frequency in India is 50 Hz, and error detector will be there that will detect whether your frequency of generated power is more than the reference or less than the reference. Accordingly, controller will control the valve of the steam input. If lesser than the desired, then it will open, increase the steam input or hydro input, water input, and vice versa. In case of voltage, we have reference voltage, say 1 per unit, and generated voltage is compared with this reference voltage. If deviation is there, that deviation can be detected with the help of error detector. That error will give signal to the controller. That controller will control the excitation of the generator. As we know that controlling excitation of generator will control the reactive power generation. Clear to you? Right. So nowadays, modern power stations are having such controllers with each unit. Let us draw a schematic diagram for a turbo generator. Say this is turbine. This is turbine shaft. Make it like this. Okay. Coupled with alternator. Say turbo generator. You can make like this or single line diagram. Okay. So this is your generator. So this turbine is moving the rotor of this alternator. Let us say this angular speed is omega, radian per second. Let us make this as a steam input to the turbine. This is steam. We are talking about turbo generator. So a steam turbine is running the rotor of this alternator, and this is a steam input. Our aim is to fix this speed corresponding to the reference frequency. You know that frequency is related with the speed. Synchronous speed is 120 f upon p. So 120 is constant, p is constant. So f depends on the speed of rotation. So you have to fix this speed corresponding to the reference frequency. Clear? Let us denote the three-phase output of this generator. Three-phase output. Let us say this output are active and reactive power. So we represented our active power generation as PG, right? Plus J QG, right? So this is generated active power. This generated active power should match PD. We are talking about single unit. So whatever the active power demand on any station is there, that demand may be optimally distributed at various units. We have studied this optimal load dispatch. So corresponding active demand will be here on this unit. Okay. Active demand on the generation is variable. So whatever demand is there, that demand is optimally distributed on the various selected units, running units. So corresponding demand will be here. So ideally, that demand must be equal to this generated active demand. If two demands are equal, then the frequency of generated power will be the reference frequency. Let us suppose that this generation is lesser than that. So if this is lesser than that, in that case, it means the steam input is lesser than the required. generation is lesser, it means steam input is lesser than the required. If steam input is lesser than the torque, two torques are here, right? One torque is provided by turbine and one torque is electrical torque which opposes this. So if these two torques are equal, only then acceleration will be zero and speed will be constant. If we are having unbalance in between these two torques, so in our case, if steam input is lesser than the required, in that case the torque provided by this turbine will be lesser than this electrical torque. So it will start decelerating. Once it decelerates, so speed decreases. Once speed decreases, then frequency will start decreasing. So frequency mismatch will be there. So our aim is to control the frequency at reference frequency. So let us see, here we have frequency sensor which senses the frequency of this output power generated power, right? So right here frequency, let us say this is frequency F, so frequency sensor, and just provide here reference frequency. Okay, F ref, REF, reference frequency. So it will sense the frequency and compare with the reference. So write and comparator. So both sensor and comparator is shown together. So whatever the generated frequency is there, frequency of generated power, that will be compared with this reference, and that error signal will be given to the controller. Which controller? That controller is controlling the steam valve. So make an arrow like this and right here steam valve controller. So if a steam input is lesser than the desired to match the active power demand, right? If steam input is lesser, then this will be lesser than difference. So that difference will be sensed by this frequency sensor and comparator, and corresponding signal will be given to this controller, which is assigned to control the valve, that is steam input. So it will sense the sign also of the error. So in this case, suppose your sign is this minus this, that will come out to be negative if this is lesser than this. So negative, corresponding to negative signal and the magnitude of this difference, corresponding action will be taken here. It will open the valve accordingly, so that the steam input will be increased. What will happen if it opens more than the desired? In that case, now this will exceed this. Then again error detector will give signal opposite than to that of the previous one. Then again it will adjust in opposite direction. So finally, in case of these two matching, the error will be 0. So this regulation is maintained continuously. This regulator regulates continuously depending upon the demand, because demand is also varying. So whatever is the demand, accordingly the valve is adjusted to match the demand on this unit, right? Okay. Now come to this reactive power generation and demand. So similar to that of active power generation and demand, these two demand and generation must match. It means QG, reactive power generated by this unit, must match to the QD on this unit demand. So again one more, sensor, voltage sensor and controller. Just write it here. Voltage sensor and comparator. So provide one reference voltage. Reference voltage. And this is excitation controller. So this signal is provided to this. So again, this is VG. Let us say generated voltage or in per unit. So this VG will be sensed by this voltage sensor and comparator. Again, this generated voltage will be compared with this reference voltage. Suppose our reference voltage is 1 per unit. So this will be continuously compared with this 1 per unit. If this generated voltage is coming out to be lesser than the reference, it means the reactive power generation by this unit is lesser than the desired. Desired means demand QG. Ideally, we have to match QG with QD, right? So what it will give the error signal to this controller. This controller is for excitation of the generator. As we know, by adjusting the excitation, the reactive power generation can be adjusted. And our aim is to match this QG with the reactive power demand on this generator. Right? So accordingly, with this diagram, we can ensure that whatever the reference frequency and voltage is desired, that will be maintained. Clear to you? So this was all about with this topic, control of load frequency and voltage. So frequency is controlled with the help of controlling the steam input to the turbine, and voltage is controlled by controlling the reactive power generation, and that is controlled with the help of excitation of the alternator. Any question? So in your syllabus, this was last topic of unit 2, just introduction to control of frequency and load voltage. Thank you very much.